Yeah, once again, very good morning for all. Here, to yesterday we completed a third unit. Here, still any doubt is there regarding in third unit, so that I can go for fourth unit. Just tell me, is it fine? Do you verified third unit syllabus already? It is fine. Then we will start the fourth unit. The silence, no response means what is the meaning of no response? Without response means what should can I understand? You understood or not?
Yes, sir.
Yes means
Start.
understood. What about third unit? I'm asking.
Third unit.
Clear?
Yes, sir.
No doubt, sir.
Yeah. Now once we have to verify syllabus. Yeah. Here response is required for all. Here not only for two or three people because here I am teaching for all students. I am expecting to understand all the students to get a good placement and good future. For that, I'm asking everyone. Only few people are responding means here I'm not teaching for only few people. The entire class. Always I'm going to think about entire class. That is why I'm asking. Yes? Is it fine about third unit?
Yes, sir.
Yeah. Just I'm going to share the syllabus of third unit again. We will check once. If you don't have syllabus, then please go to website, college website. In that syllabus is there. You can download it and you can verify. Please. Here, unit third, already we completed. Again, I am going to read. Then what are the topics we are covered and everything is there to cover. Then you please understand. Search trees, binary search trees, definition, implementation, operations, searching, insertion, and deletion. Yeah. Next, AVL trees, definition, height of an AVL tree, operations, insertion, deletion, and searching. Then a red black tree and split trees. Yes, we are covered all right. Anything is missing as per our syllabus? Hello? Hello?
Yes, sir.
Anything is missing?
No, sir.
Yeah, we covered all. It is clear.
Yes,
Yes, sir.
sir.
Right. Here next coming to fourth unit. Today we are going to start the fourth unit. Here I don't know your section response is very less, but even some interesting topics also we are discussing. You people are not responding. I don't know why. Now coming to the fourth unit. Here fourth unit again classified into two categories. One is graphs, another one is the sorting. First of all, we are going to finish up the graphs. Here we have the graph syllabus, only two topics actually, basically graph implementation methods and traversal methods. Only two things are there actually for the graphs. Okay, but we must know what is graph and how it will work and what are the properties. All these things we must know before starting the graph discussion. Now, can anyone knows what is a graph? Earlier, any knowledge you people are having? What is the meaning of graph? Response is required. Hello, is it audible? Hello? Hello? No one is. Please unmute and respond. If you know
Yes,
or
sir.
you don't know,
Hello.
not a problem. Yeah, you can give some answer. If you know, then you tell. If you don't know, you tell we don't know. But if you are silently listening, means what is the use? But at the time of attendance, everyone
Sir,
is
it is
responding.
a pic-
Uh, yeah, tell me.
it is a pictorial representation or a diagram uh, that shows the relation between two objects in the form of
Mhm.
pictorial representation.
Yeah, yeah. The generalized definition is right. Still, any other wants to tell graph,
It
especially in
comes
your
under
mathematics.
non-linear
Yeah, it comes
it
under
comes under
nonlinear. Kirtana.
data structure.
Yeah, right, Kirtana. You used your intellectuality actually today. Yeah, right answer. Yeah, still, so that is what observations. This is what exactly the observation what is going on. Yeah. Now, when you observe our syllabus, we know your data structure is classified basically how many types?
Two types,
What are those, Kirtana?
linear and non-linear.
Linear and non-linear. Very good. Here, linear means we are going to arrange the data in a sequential fashion. Non-linear means we are going to arrange the data in a non-sequential fashion. What are the data structures we discussed in a under linear data structure?
Linked list and double linked list.
Hmm.
Circular linked list.
Hmm.
Stack and queue.
Stack and queue.
Stack and queue. Very good. Sir, what are the non-linear data structure we already discussed?
Trace.
Only trees we discussed. One more topic is graphs. Here, non-linear means the data is not arranging in a linear fashion. That it can take any order. Okay, maybe the random, maybe the hierarchical, maybe any order. The non-linearity. Here, one concept already we discussed about trees. Today we are going to discuss about uh, another non-linear data structure, which is graphs. Here, actually, we have more similarity from tree to graph. So that is why, first of all, we must understand the drawbacks of the tree. Based on that, we can understand why the graphs are required. Here, coming to trees data structure, it is also a non-linear. We know very well. Even we learned all such trees also. For all this, here one thing I will tell you. Uh, when you want to traverse in a tree, always you must be start from hello.
From root no.
In a tree data, yeah, root node means in your section now 45 people are there in this meeting. If 45 people want to traverse in a tree, all of you must start from where?
61.
Hello. I'm asking one tree is there. All students are going to traverse in the tree. All must be start from which node? Hello. 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 Is it audible?
Yes, sir. Hello.
Yeah, my question
Actually,
is,
root
one tree is there. Now, all, for example, if you consider 100 people, they want to traverse in that particular tree. Those 100 students must be start from which node?
From root node.
Root node only. If they wanted to start in from other node, is it possible in a tree?
No, sir.
Different users from different nodes, not possible. So this is the drawback. Here means everyone, here any case or any situation, they must start from root node. For example, here one particular, the Google map, already, you people are aware of that Google Maps, right?
Yes,
Yes,
sir.
sir.
Yeah, this is great example for graphs actually. Our trees are going to failure when you want to construct the map. For example, if you take a Google map, here one person is at Secunderabad, another person is at Medchal, another person is at Karimnagar, another person is at Khammam. Here now, if you use a tree data structure, if they want to use graph, all people must be start from only one location. If it is Hyderabad is maybe the root node, all must be start from Hyderabad only. Yes or no?
Yes, sir.
Yes, sir.
But is it good idea? Because I am at Khammam, now I am at Khammam, someone is at Hyderabad, someone is at Karimnagar. Now all they must be start from Hyderabad means it is a good idea. Is it good idea?
No,
Is it no?
No, sir.
Because everyone they will start from their location. Then they want to find the destination. Maybe the CMR Technical Campus is the destination. Everyone they must start from their own location, right?
Yes, sir.
That's why here some of the real-time applications our trees are not going to solve. That's why they implemented graph. Here you can choose any node as a root node, any node as a start node. Here in a tree, there is a drawback for that graph. They implemented the structure is you can any situation they can choose any node as a start node. You can start from A, you can start from B, you can start from C. Whatever the node you wanted to traverse from start node, you can start it. And that's why here your Google Maps, the basic data structure is our graphs only. Not only Google Map, here railway tracking mechanism, okay, even bus tracking mechanism and internet connectivity. Here all the devices are connecting through some internet. Here that is also with graph only. Anyone they can use not only one system. Here now I am asking some question, you are giving your answer. Here there is no only one start point. We can use any point as a start. Here there is a graph technique background. The graph data structure is going to work. Here, that's why here these are the real-time applications of the graph. Understand?
Yes, sir.
Yeah. So the first rule is in a graph we can start. We can use any node as a start node, and even uh, you can visit any node again and again also in a graph. If you observe a tree, always you must be start from root node, and once you are going to reach to the leaf node, here you cannot move to another node. Yes or no? That is the end node. Yes
Yes,
or
sir.
no? But in a graph, you can visit, you can move to back, you can visit to other node also. There is no leaf nodes. They all are connected. Then there is no chance of the visit. Maybe a leaf node mechanism is not there. Maybe the end node is there, but there is no chance of the leaf node. Okay, understand?
Yes, sir.
Yeah. So this is the basic difference from tree to graph. Even the tree, the definition, what we have used the definition, all the tree is a collection of nodes and edges, correct?
Yes, sir.
Same definition you can use here in a graph also. The graph also a collection of nodes and edges. But the thing is, always in a tree you start from root node, but here you can choose any node as a start node in a graph. Clear? This is what exactly the difference from graph to tree. Understand? Hello.
Yes, sir.
Now my screen is visible now. Is this my screen is visible?
Yes, sir.
Hello. Yeah. Now today we are going to understand what is a graph and terminology of the graph. Very important. If you know this, then remaining things we will learn in the next class very easily. Now, already I told you very clearly, a graph is a collection of nodes and edges. Already I told you very clearly, same definition we can use, but sometimes here the nodes are called as vertices and edges is called as arcs. That's why you can tell the definition of graph another way is that the graph is a collection of vertices and arcs which vertices are connected with arcs. So this is the definition. Like collection of nodes and edges, we can tell like vertices and arcs. Arcs is nothing but edges. Vertices is nothing but a nodes. The same thing. The representation is also same. We can use circle for vertices and links for arcs like edges. Clear? The definition of the graph is clear now.
Yes, sir.
Yeah. Now, generally, graph we will represent with capital G. G equal to V comma E. This is the formula for graph. So earlier, actually, for engineering students, they are having graph theory. One subject is there for the first year, very important. Okay. Anyway, we can understand now. G equal to V comma E. G is going to represent the graph, and V comma is nothing but V is nothing but a vertices, and E is nothing but a edges. Here means the representation of the graph is G equal to V comma E. Means it is a combination of vertices and edges. This is the meaning. Clear? Clear about this formula for graph? All of you clear this? Hello.
Yes, sir.
Now, for example, one graph I am taking. So this is a graph. Here, you know, same like tree, if you are going to looking like it is a tree, but there is no chance of a root node, means start node as a root node. We can sometimes you can start from A, someone will start from E, someone will start from D. Here, anyone they can choose any node as a start node. There is no problem at all. Are you clear? Are you clear?
Yes, sir. Yes,
If you
sir.
take, yeah, if you take a tree compulsory, you must be use A as a start node, correct?
Yes, sir.
Yes or no? This is a tree. If you consider this is a tree, then you can make it A as a start node. Here I am going to tell one more difference. Here, all the trees we can convert as a graph. So once it is converted as a graph, here you can start from B or you can start from E or you can start from any node. Understand? But don't tell a root node. You must be start. If you consider this tree as a graph, are you clear? Hello. All trees you can consider as a graphs. But once you are considering tree as a graph, the start node you can take any node, not only the root node. Understand?
Yes, sir.
Yeah. Now one more difference also I will tell you. Here in a graph, there is a chance of cycle. The cycle means you can move from A, B, D, again you are visiting A. Here A, B, D, A means in a path. Here A again we are going to visit A, B, D, again A. Now there is a chance of cycle. You can call this also a graph, this also a graph. But sometimes there is a chance cycles are in this graphs. Here cycles are possible in a graph. You don't tell graphs always contains cycles. So there is a chance, maybe there is a chance of cycles in a graph. Because you can consider this also a graph, but here there is no cycle. But here the cycle is there. That's why here I cannot tell compulsory every graph contains cycles. Only we can tell there is there is a chance of the cycles in the graph. Clear? Hello? Hello?
Yes, sir.
Yeah, that's why you can understand here are there is no cycle in a graph tree, but there is a cycle, there is a chance of cycles in a graph. So that's why here you can convert, you can call all trees as a graph, but all graphs not a tree. Clear? Because graph is having sometimes cycles. That's why you cannot consider all graphs as a tree. Understood now? The differences from tree to graph. Hello. Timing,
Yes,
timing. Yes. Yeah. Right. Now, write formula G equal to V comma I. Here, vertices are, how many vertices are there here in this graph? What are those? Tell me first. In this graph, how many vertices are there?
5.
Five. What are those? A, B, C, D, E. Correct.
Yes, sir.
Now, edges. Edges is nothing but, arcs. Here how many edges are there? Generally, in a tree data structure, your number of nodes are n, the number of edges are n plus 1 in tree data structure, correct?
Yes, sir.
But coming to the graph, here there is no chance of this formula. Here, if a number of nodes are 5, you cannot tell number of edges are 5 plus 1, 6. It is not possible in a graph. Here, we can have more number of edges or less number of edges than this vertices. That's why this formula can't work in a graph. Are you clear? Are you clear?
Yes, sir.
Yeah. Now tell me how many number of edges are there here?
7.
How many number of edges? 7 edges. What are those? A to B, A to C, A to D. Right? Here, now from B. Here from B, you no need to consider B to A. Already A to B is there. That's why B to D and B to E. Are you following? Next, C to D. Next, D to E. Are you following this?
Yes, sir.
Understand? Sir, if you consider A to B, no need to consider again B to A. Are you clear?
Yes, sir.
Everyone is clear? So this is the way we can consider edges in a graph. Okay? Hello?
Sir.
Hello? Clear this? No response is coming. How can I understand if you are following or not? Is it clear? Yeah. Now coming to the terminology. Today we are going to learn properties or maybe the terminology of the graph. So this class onwards, you can understand how to represent the graph and what are the procedures and how to implement and how to traverse. Okay, right. Coming to the terminology, first one is the vertex. What is the meaning of vertex? Vertex is nothing but what? What is the meaning of vertex? Vertex is nothing but a hello node. Are you clear? So these are the vertices A, B, C, D. Clear?
Yes, sir.
Yeah. Please don't confuse. In graph, we are going to call vertex. That is a node only. Please. Now coming to the edge. Edge is nothing but what? Edge is nothing but what? Sometimes it is called as arc. The edge is what? we are going to connect two vertices using this edge. There is a link between two nodes. Yes or no?
Yes, sir.
Yeah. Now in a graph, we have three categories of edges. In a graph, very important, please listen carefully. These terminologies we are going to use for the implementations. Okay, that's right. Please listen carefully. Now, here three categories of edges are available in a graph. One is undirected, directed, and weighted. We're coming to what is undirected edge. The undirected is nothing but there is no direction. For example, I'm going to draw undirected edge. A, B. Now this edge is a undirected edge. Why? There is no direction. Means you can move from A to B as well as you can move from B to A. Are you clear? This edge is called as undirected because we can traverse from A to B as well as B to A, vice versa. That's why this is a undirected. There is no direction. Are you clear?
Yes, sir.
Hello? Yeah. Now coming to the directed edge means there is a direction. For example, here A. Now one edge is there that is having direction. Here in this edge we can traverse from B to A only. We cannot traverse A to B. Such type of edges is called as directed edge. Are you clear? We cannot traverse from A to B in this edge. Only we can traverse from B to A only. That's why it is a directed edge. Are you clear? Hello? Respond quickly. Hello? Hello? Yeah. Now coming to the weighted edge. So weighted edge is somewhat different mechanism. So always the edge contains some label. For example, so maybe A to B or B to A. Even you can use this weighted edge for directed edge or undirected edge. Not a problem. Yeah. Here, but the edge contains some label. So what happened? So these two are what? Weighted edge means here every edge contains some label. Here the label is in the form of distance or in the form of size or in the form of weight or in the form of distance or etc. etc. That means every edge is having some weight. So such type of edges are called as weighted edge. That means I want to traverse from A to B. If the distance is 2 kilometers, I am taking. Here even temperature, anything, any parameter you can take it as a label. Here same way I am using here directed edge, but label is there. So such graph is called such edge is called as weighted edge. Are you clear now? These two. The weighted edge is clear. This is very important. These edges. Hello. Hello. Is it audible?
Yes, sir.
Is it clear? Undirected, directed, and weighted edge. Everyone has to respond. Hello. The people are not responding. I don't know. You are following or not. Are you following?
Yes, sir.
Sir.
Yeah. Now clear. Undirected, directed, and weighted edges.
Yes, sir.
Right. Now coming to the undirected graph. You know very well. Your undirected graph means that graph contains only the undirected edges. Such graph is called as undirected graph. So now I am drawing one graph. Here this is a undirected graph. Why? Why it is a undirected graph? Tell me. Why this graph is a undirected? Hello?
We can direct any direction.
No. I am asking why this graph is a undirected. I am not asking the undirected edge. I am asking undirected graph. Why this graph is a undirected? Hello? People are not responding. Are you following?
Undirected edges.
Yeah, that graph contains only undirected edges. Yeah, this is undirected, this is undirected, this is undirected. That's why this graph is an undirected graph. Yeah, these definitions are very important. Carefully, you need to give the answer. It is more helpful for your placements also. Now, coming to the directed graph. Means directed graph means, now tell me what is the directed graph? What is the directed graph? Hello?
Which contains directed edges.
Yeah, the graph which contains only directed edges. That is called as directed graph. Clear? Now, mixed graph. Here, mixed graph is nothing but it is a combination of all edges. What are the edges are available? Directed, undirected, and weighted. Are you clear? Are you clear?
Yes, sir.
Here, that graph contains all the combination of edges. Here, this is the direction, and this is a weight, and this is the undirected. So this graph is called as mixed graph. Clear? Are you clear?
Yes, sir.
Yeah. So this is a mixed graph. So it means it is a combination of all the edges. The graph is called as mixed graph. Now coming to the end vertices or end points. So please listen carefully. End vertices or end points. Nothing is there. Here when we are going to traverse, in a graph, for example, in this graph A to C. Now we have to traverse A, B, then C, then C. So now what are the end points? A and C is the end points. So A and C is the end points. Are you clear now? Are you clear? So in middle, whatever the nodes we are going to visit, we no need to remember that. Only the end point is start and destination. The start is A, the destination is C. That's why these are the two end points. Clear this?
Yes, sir.
Yeah. Next one is the origin. If the start point is called as origin, this A is the origin. For this traversing, we have to move A to B, B to C. Here we have taken the start point is A for this traversing. That's why this A is the origin. Clear? Clear?
Yes, sir.
Yes, sir.
Destination. What is the destination? C is the destination. When I want to traverse from A to C, we are moving from A, B, C. Now A is the origin, C is the destination. I can tell the end point one more definition. It is a combination of origin and end point is a origin and destination is a end point or end vertices. Clear this? Clear this?
Yes, sir.
Yeah. Next, very important one, adjacent. This adjacent mechanism is very, very important. Please try to understand the adjacent. For example, the graph is like this. A, B, C. Here, adjacent is nothing but connected node. Here, A, what are the adjacent for A? Tell me now.
BC.
Yeah, B and C is adjacent of it. This is very, very important. for our graph data structure implementation. That's why please follow and understand. Anything is there, please ask me. Now, what are the adjacent for C?
AB.
Very good. If I draw a tree like this, please consider blue line tree. Now tell me, what are the adjacent nodes of A for this directed graph?
CB, sir.
CB, very good. What are the adjacent nodes of B?
C, sir.
Only C, very good. Okay, this is only connected. This is not connected. Yes or no?
Yes, sir.
Yeah, very good. What are the adjacent nodes of C?
No, sir. There is no
No,
adjacent.
zero. Zero adjacent nodes are there for C, correct?
Yes, sir.
Yeah, very good. Yes. So this is the way must be understand the terminology. Next one, incident. So what is meaning of incident? For example, I want to traverse A to C. Already I told you. You are going in this graph I am taking A, B, and C. So I want to traverse from A to C. Then I have taken this path A, B, C. Now you know A is what? What is the meaning of A here? Hello? What is the meaning of A?
Origin.
Origin. What is the meaning of C?
Destiny.
Destination. Here in middle, what are the nodes we are going to visit? Those nodes are called as incident. Understood? For traversing from origin to destination, we are going to visit some of the nodes. So those nodes are called as incident nodes or incidents. Understood now?
Destination.
Clear now? Clear? Hello? Are you clear this incident? No response. Hello?
Yes, sir.
Yeah. Now coming to the outgoing degree and incoming degree. Please remember this outgoing degree and incoming degree only work for directed graph. It cannot be work for undirected graph. So what is the meaning of outgoing edge? Here means outgoing edge is nothing but it is connecting to another node. That is the outgoing edge. Here connecting to another node is outgoing edge, and connecting to from other node to that node, that is called incoming edge. Here A is having how many outgoing edges? Here in this graph, 2. Yes, very good. Here, how many incoming for A?
0.
0.
Yeah. For B, what are the outgoing edges?
1. C.
1.
What is the incoming? What is the incoming?
1.
1. Yeah. For
1,
C,
sir.
how many outgoing for C?
0.
For incoming?
2.
2.
Okay, this is the way we can understand the outgoing edge and incoming edge. Clear?
Yes,
Yes,
sir.
sir.
Now coming to the degree. Here, what is a degree? Here, degree is only work for undirected edges, not for a directed graph. It is going to work for undirected graph only. Here, number of edges of that node is called as degree of that node. Here, what is the degree of A here? What is the degree of A? What is the degree of A here?
2, sir.
So every node is having 2, right, for degree in this given graph. Understand?
Yes, sir.
Yeah. Now coming to next topic is in degree and out degree. Very important. Here this in degree and out degree only works for directed graph. Are you clear? Hello?
Yes,
Yes,
sir.
sir.
Yeah. In degree and out degree. It means incoming edges is number of incoming edges is called in degree. Number of outgoing edges is called as out degree. Now, what is the in degree of A? Number of incoming edges for A,
0.
0. What is the out degree of A?
2.
2.
Very good. Yeah, same. Here, number of incoming edges is called as in degree. Number of outgoing edges are called as out degree. Here, very simple. This in degree and out degree, incoming edges and outgoing edges only possible in a directed edges, not in the undirected edges. Clear?
Yes, sir.
Now, next one is a parallel edge or multiple edges. The parallel edge and multiple edges is nothing but, for example, here A and B. Here, or you can write like this also, A and B. These edges are called as parallel edges. This is a undirected, this is a directed. Here, parallelly, we are going to connect A to B for one edge, and again we are using one more edge for that. Then that is called as parallel edge. In directed edges also we can use this. Such situations are called as parallel edges. The parallel edges are not good mechanism. We are not going to use parallel edges anyway in the academic. Okay, but it is there. Clear? These parallel edges are multiple edges. Clear?
Once again.
The parallel edge or multiple edges is nothing but here we are going to provide parallelly two edges. Here A to B, one edge is there. Again, we are going to draw here one more edge B to A or A to B. These two are parallel edges. But there is no use, there is no advantage. We cannot use this in academics. Even in directed edges also we have like that. But this is not a good idea for implementation, but it is there. Understand?
Yes, sir.
Yeah. Now coming to the self loop. The self loop is nothing but that edge is going to have origin and destination is same location. For example, now we have A to B, B to C, C to A, but C to C also there. Here, the origin as well as destination is same location, same node. Such type of edges are called as self loop edges. Are you clear?
Yes,
Are you
sir.
clear about self loop? Hello? Are you clear about self loop?
Yes, sir.
Yeah. Next one is a very important simple graph. The simple graph is nothing but the graph which not having self loop as well as parallel edges. A such graph is called as simple graph. Clear now? That's why parallel edges and self loops are not uh, means no need to use all the cases. Only some specific cases we are going to use. It is not suggestible to use in the graph representation. The simple graph is nothing but the graph which is not having self loop as well as parallel edges is called as simple graph. Clear this?
Yes, sir.
Yes. Now the last terminology is path. The path is nothing but when we are going to travel A to C, what should we do? Your origin is A, then moves to B, then moves to C. So this is called as path. Is it clear?
Yes, sir.
Clear? You know already same in your tree also we use the same way. Clear this? Path is nothing but we are going to traverse from one node to another node with the help of edges. That representation is called as path. Correct?
Yes,
Is
sir.
it correct? Then tell me what is the path length here? This is a if you take this is a path for your traversing. And what is the path length here? How to calculate path length? Hello? How to calculate the path length? Already we know. This is in your tree data structure also. We discussed about this. How to calculate path length here? What is the path length? Hello?
It's the degree of the tree.
Path length, yeah. Why you are involving degree? Here, A to B, B to C. Here, how many number of,
3, sir.
not nodes, how many number of edges are there?
2, sir.
So the path length is 2 only. We discussed already. People are confusing. Sir,
Sir,
don't
but
consider. Huh?
sir, for degree also 2, no, sir.
I am not asking degree. I am asking path. Path means traversing. For example, I want to move from A to E. Now tell me, some people will be traversal A to B, B to E. Some people will be traverse A to C, C to D, D to B, B to E. Correct? Yes or no? From Secunderabad to Sema Technical Campus, if you want to traverse, someone will come via Kompally, someone will come via Boinpalli, someone will come via Medchal, someone will come, etc., paths. Yes or no?
Yes, sir.
Now, yeah, this is also going to reach the source to destination, this is also going to reach the source to destination. And even you can write A to B, B to D, D to E also. Correct? Yes or no?
Yes, sir.
Sir, in this case, here this is the middle parts are incidents, you know very well. So the starting is origin, the ending is the destination. Now for this traversal, here we are visited how many edges here? In this path, how many edges?
2.
In this path, how many edges?
4.
4.
Edges. 4? Okay, 4. In this path, how many edges?
3.
Yeah. So out of this, which is the best path? The path which is taking
Less.
less visiting of edges. That is true. Now this is the best path. We have to choose this is the best path. So already we know this is used in the tree also, the same way. Now clear? The path is different,
sir.
degree is different. The degree is nothing but what is the degree of A? The number of connected edges, 3 for A. For B, 3. The degree is different, path is different. Path is nothing but when you are going to traverse from source to destination, how many number of edges we are going to traverse. That many number of edges is called as path of the particular path size of the particular path. Clear?
Yes, sir.
And path length. Yeah. Now understood all these terminologies, everyone?
Yes, sir.
All of you understood this terminology of graph. Okay, if it is yes, tomorrow we will discuss, or in the next class we will discuss in the other topics. Okay, please go through the